In this video, we are going to be calculating the formula of a hydrate. Really, we're just trying to figure out how many water molecules there are for every formula unit of the ionic salt. In class, we talked about the fact that a hydrate is an ionic compound that has water molecules that have been absorbed or incorporated into its crystal structure. So I'm going to start out by reading the problem, and then we're going to walk our way through this. Before we start with the calculations, though, I'm going to point out the fact that it's really important to pay attention to our significant digits while we are calculating this. Just because, especially with problems like this, if we're off by rounding a little bit, if we're not reporting our numbers with the correct number of sig figs, in some of these problems, you will get the wrong coefficient for water in your formula. I've seen it a lot, especially with some of the problems that are in our practice packet. So just be mindful of that. All right, so let's go ahead and get started. This problem says a sample of a hydrate of chromium 3 chloride with a mass of 3.572 grams was heated until no more water was released. The mass of the resulting anhydrous salt was 2.663 grams. Determine the formula for the hydrate. So a couple things I want to point out first. This word anhydrous right here, this means without water. So this is the mass of the dry salt. After we heated it up, all of the water evaporated out of that compound, and now there's no water left, so it's the dry salt. And when it's asking us, when we're determining the formula for a hydrate, like I said earlier, we're just calculating how many water molecules to incorporate into the formula, or are incorporated into the formula for that substance. So, for example, if I was going to write the formula for chromium 3 chloride, I'd have this, and then a number here, a big coefficient, and H2O. So we're solving for X here. We're trying to figure out how many of those water molecules are in that hydrate. So I'm going to start by listing the information I have. I know the mass of the hydrate itself. That is the salt plus water. So here's the mass of the hydrate. I have 3.572 grams of chromium 3 chlorate, and I'm just going to put H2O here, even though we don't know what the hydrate is. That just tells us always label with the unit and the identity of the substance. It's very easy in chemistry to get your numbers mixed up. So if you have everything labeled all the time, you're more likely not to get those numbers mixed up. All right, the next piece of information I have is the mass of the anhydrate. So the mass of the dry salt, which is 2.663 grams of chromium 3 chloride. And if I'm looking up here at this formula, what I'm really doing is I'm finding the ratio of water molecules for every formula unit of chromium 3 chloride. So if I'm going to be determining an amount for water, I also need to know down here how much water was evaporated. I need to have an amount for water. So my mass for water is something I need to find. And in order to find that, all I need to do is subtract these two numbers. So this is the total mass with the water and the salt in it. And if I just subtract the mass of just the salt, whatever's left is the mass of the water. So I'm going to go ahead and do that in my calculator. I'll go ahead and draw this out here so you guys get a visual of what I'm doing. I'm subtracting these two numbers from each other, and I end up with 0.909 grams of H2O. Okay, this number right here, the mass of the anhydrate and the mass of the water, are the two most important numbers that I need in order to perform these calculations, okay? And that's not a negative sign, that's just there. Okay, two most important numbers. So because we can't compare the numbers of particles when numbers are expressed in masses, we have to convert to moles. I can't compare grams to grams of one substance to grams of another substance and know anything meaningful about the numbers of particles that I have. But if I convert everything to moles, 1 mole of one substance is equal to the same number of particles of moles in another substance. So then I can compare and I can figure out the ratios of different substances. So in order to convert these to moles, I need to know the molar mass of both chromium 3 chloride and water. In class, I told you that we're going to use the molar mass for water in here so often that it's probably just a good idea to memorize that. So the molar mass for water is equal to 18.02 grams per mole. Okay, it's a little slash sign right there. All right, and then the molar mass for chromium 3 chloride, we need to calculate that. So we're going to calculate that down here. For this compound, I have chromium and chlorine. I have 1 chromium atom and 3 chlorine atoms. And when you're pulling mass off the periodic table, you need to round all of those numbers to 2 decimal places. Because when I do the calculations for things that you guys are submitting on It's Learning, that's what I'm doing. So if you're not rounding the same way I am, you're going to get a slightly different answer, and it's going to get counted wrong. So 2 decimal places. Chromium is 51.996 on the periodic table. If we round that up, it's going to be rounded up to 52, but you still need 2 decimal places. 52.00. So report those with zeros. Okay. Chlorine is 35.45. And these are both grams per mole. All right, so in my calculator, if I multiply 35.45 times 3 and I add 52, then I get the molar mass for chromium 3 chloride, and that is 158.35 grams per mole. All right, so there are my molar masses. Now I can convert moles of chromium 3 chloride, grams of chromium 3 chloride to moles, and so I could do the same thing for water. So let's go ahead and do that down here. I'm going to start with my anhydrate, so 2.663 grams of chromium 3 chloride. Remember, I'm going to use my molar mass as a conversion factor here, so 158.35 grams goes on the bottom because I need grams to cancel out. And it only cancels out if it's on the top of one fraction and the bottom of the other, okay? So over 1 mole. This is my conversion factor for my molar mass. See how grams per mole is listed up here? I could put grams on top if I need to, but in this case, grams needs to be on the bottom so that it cancels out. All right, plug that into my calculator, and I get 0.01682 moles of chromium 3 chloride. Okay, now I need to convert moles of water, so I'm going to start with 0.909 grams of H2O. Again, I'm going to use my molar mass as a conversion factor, so 18.02 grams over 1 mole of H2O. And I'm going to end up with 0.0505 moles of H2O. So my end goal is to figure out how many water molecules for every unit of chromium 3 chloride. So my last step is to divide the moles of water by the moles of the anhydrate. In the hydrate calculations, just remember in that last step that water always goes on top. So 0.0505 moles of H2O divided by 0.01682 moles of chromium 3 chloride. Plug that into my calculator, and I end up with 3.00 moles of water for every mole of chromium 3 chloride, right? And that's not quite my final answer, but that is what I'm going to be putting into my final answer. So my final answer is I want you to write the formula and the name for this hydrate. So I'm going to start out with the formula. So chromium 3 chloride, and I'm going to put a 3 here, and then H2O. That 3 is what we calculated. And then to name this, we just name the ionic salt. So in this case, it's chromium 3 chloride. And then we're going to use prefixes, hydrate. So here's our final answer right here. So you need to be able to both write the formula for the hydrate and name the hydrate. Okay? If you have any questions about this, you can write them down and come on and see me in class or send me a quick email. All right, I'll see you.